Hi everyone, this is Jagjit, and in this question we're going to be solving for KSP. The question tells us that we have a saturated solution of BaF2 where the concentration of F minus is 8.6 times 10 to the power minus 3. And the question is asking us to find the KSP. So guys, the very first step in all these questions is going to be we need to write the dissociation equation. Okay, so we're going to get our BaF2, which is a solid, and we're going to break it up into its ions. Okay, when BaF2 breaks up into its ions, you're going to get Ba2 plus aqueous plus F minus aqueous. Now we just need to make sure we balance this equation. We have one Ba and one Ba2 plus, so we're good for that. For F, we have two of those. However, on that side, I only see one of that. So we need to put 2 in front. Now the question did tell me that the concentration of F minus was 8.6 times 10 to the power minus 3 molar. And this is a fully saturated solution, which means the concentration of Ba2 plus. Guys, let's look at the molar ratio. There's 1 in front over here, and there's 2 in front over there. That means the concentration of Ba2 plus is just going to be half of that. So that's just going to be this number divided by 2, which will just be 4.3 times 10 to the power minus 3 molar. And guys, our KSP expression is just going to be our product, guys. So we're going to have concentration of Ba2 plus times concentration of F minus. Now there was a 2 in front. That means that 2 is going to land and become the power. It's going to land in the exponent. Okay, so let's plug in the numbers. Ba2 plus concentration was 4.3 times 10 to the power minus 3, and concentration of F minus was 8.6 times 10 to the power minus 3, and we need to square that. Guys, I want you to be very careful. Make sure you don't forget the square, okay? Anytime there's a number in front, we need to square it. So I'm going to let you guys punch that in your calculator. And if you've done that correctly, this should give you 3.18 times 10 to the power minus 7. So that's going to be your KSP expression. And again, folks, make sure you take care of the sig figs, okay? Some of the teachers are very picky about that. So make sure you look at your numbers and you write your answer as a proper sig fig. So our final KSP is 3.2 times 10 to the power minus 7. We'll do a couple more examples. Next up, the question says we have a saturated solution of MgOH2. We have a saturated solution of MgOH2. And they're asking us to find the concentration of Mg2 plus. Again, as a very step, we're going to write our dissociation equation. So MgOH2 is going to break up. And that's going to give me Mg2 plus aqueous plus OH minus aqueous. Now we need to make sure the equation is properly balanced. I have one Mg, one Mg2 plus, so we're good for that. I have 2 OH minus, so we need to put 2 over there. Now guys, what's going to happen is, if this guy loses X, if it dissolves X amount, this is 1 to 1, that means this is going to go up by X. Okay? Now this has a 2 in front, means that's going to go up by 2X. So my concentration of Mg2 plus is going to be X, and my concentration of OH minus is going to be 2X. And we're going to write our KSP expression, which is just concentration of Mg2 plus times concentration of OH minus, except there's a 2 in front, so that's going to become the power. Now, concentration of Mg2 plus is just X, so this is X times 2x. Concentration of OH minus is 2x, so we're going to plug in 2x over there. So it's 2x whole square. So this just becomes 4x cubed. And guys, now I want you to look at your solubility chart and find the KSP of MgOH2. So you're going to look on your solubility table and you're going to find the KSP of MgOH2. I'm just going to save time at my end. This should be equal to 5.6 times 10 to the power minus 12. Okay, this should be equal to 5.6 times 10 to the power minus 12. And now we're going to be just isolating x. So as a first step, we're going to divide both sides by 4. So our x cube is just going to be 5.6 times 10 to the power minus 12 divided by 4. Okay, I'm going to take my calculator. I'm going to punch that in. So it's going to be 5.6 times 10 to the power minus 12 divided by 4. And that gives me 1.4 times 10 to the power minus 12. And now to solve for x, we're just going to take the cube root. Now guys, some of your guys' calculator is going to have the cube root button. Now if you don't have a cube root button, a cube root just means you're going to take this number, put brackets around it, and raise it to the power 1 over 3. Okay? So if you don't have a cube root button, you just take that number and you raise it to the power 1 divided by 3. And that should give you your answer, which is 1.1 times 10 raised to the power minus 4. Okay, guys? And that's your, x is your concentration of Mg2+. Now, we could have also found our concentration of OH minus, folks. So let's write the concentration of both of those ions. My concentration of Mg2+ is x, which is 1.1 times 10 to the power minus 4. And my concentration of OH minus is 2x, which is just going to be 2 times that number, 2 times this number, which is just going to be 2 times 2 times 10 raised to the power minus 4. So that's how you're going to get the concentration of ions for any saturated solution. Okay? We'll do a couple more examples. So question says, find the mass of AgIO3 which will dissolve in 2.5 liters. Which will dissolve in 2.5 liters. So guys, as a first step, we're going to write the dissociation equation for AgIO3. So we're going to take our AgIO3 solid, and we know AgIO3 is made up of Ag plus and IO3 minus. So we're going to break it up in ions. So we're going to have Ag plus aqueous plus IO3 minus aqueous. Again, we know this is going to lose X. Due to 1-to-1 ratio, this is going to gain X. And this is also 1-to-1, so this is also going to gain X. We write our KSP expression. That is just going to be concentration of Ag plus times concentration of IO3 minus, which is just X times X, which is X squared. And we're going to make that equal to our KSP of AgIO3. So you're going to look on your solubility chart, and you're going to get the KSP of AgIO3. Now, just to save some time, I see that the KSP of AgIO3 is going to be 3.2 times 10 to the power minus 8. So to get our X, we're just going to take the square root of that number. Now make sure you put brackets while you're square rooting it. Now if you punch it in properly, you should get 1.79 times 10 to the power minus 4. So that's your X value, which is your concentration of Ag plus and your concentration of IO3 minus, and it tells you how much AgIO3 had lost. Okay, so this is how much of AgIO3 was dissolved. So in other words, we can say 1.79 times 10 to the power minus 4, and I'm just going to rewrite this as moles per liter. So these many moles of AgIO3 were dissolved in 1 liter. Now the question is asking us how much mass of AgIO3 will dissolve in 2.5 liters. So first what we're going to do is we're going to ask ourselves how many moles are going to be dissolved in 2.5 liters. We're going to times this by 2.5 liters. Liter cancels. So this tells me how many moles are dissolved in 2.5 liters. But that question is asking me to find the mass, which is grams. So in the next step, we're just going to turn these moles into grams. So we have moles of AgIO3 at the top. I put moles of AgIO3 at the bottom. And 1 mole of AgIO3 is going to be equal to its molar mass. So you can find the molar mass at your end. Now, when I punch it in at my end, I get 282.8 grams of AgIO3. Now your moles are going to cancel with moles. So guys, you're going to take this number, times it by 2.5, times it by 282.8, and you should get 0.13 grams of AgIO3. So these are the grams of AgIO3 that are going to dissolve in 2.5 liters. Okay? This is a good question. I want you to make sure you practice this a couple of times. Next up, question says we have 2.2 times 10 to the power minus 4 grams of CuI. So we have 2.2 times 10 raised to the power minus 4 grams of CuI, which will dissolve in 1 liter. This will dissolve in 1 liter. And the question is asking me to find the KSP. Again, guys, very simple thing. Right now, we know the grams that are going to dissolve in 1 liter. We need to change it to moles per liter, because moles per liter is just going to give us molarity, which is concentration. So as the first step, we're going to say we have 2.2 times 10 raised to the power minus 4 grams of CuI, and this dissolves in 1 liter. And now we're going to just change these grams to moles. We have grams at the top, we're going to put grams at the bottom. And we're going to say 1 mole of CuI is going to be equal to the molar mass of CuI. Okay? I'll let you find the molar mass at your end. It should be 190.4. So the grams and the grams are going to cancel. We're just going to take this number and divide that by 190.4. When you divide that by 190.4, you should get 1.155 times 10 raised to the power minus 6 moles of CuI. And these many moles are going to dissolve in 1 liter, which means the concentration of CuI is equal to 1.155 times 10 raised to the power minus 6 molar. Now we have the concentration of CuI, and the next step, we're just going to take our CuI and we're going to break it up into its ions. So we're going to get Cu plus aqueous plus I minus aqueous. Okay, we're going to get Cu plus and I minus. The concentration of this was 1.155 times 10 raised to the power minus 6. Now these are all 1 to 1, so the concentration of this will be the same, and the concentration of the I minus will be the same as well. Now I'm going to write my KSP expression, which is just going to be my concentration of Cu plus times my concentration of I minus, which is essentially this times this, And because these are the same, you can also just square them. I'll let you punch it in at your end. If you've done it correctly, you should get 1.3 times 10 raised to the power minus 12. So this is how you're going to get your KSP. Okay, guys? So bottom line is, anytime you see grams converted to moles, from that you're going to get your molarity, your concentration. Once you have your concentration, finding KSP will be very easy. Okay? We'll do one more example. Question is asking us to find molar solubility of silver chromate. So we have silver chromate. So guys, as a first step, we need to know what the formula for silver chromate is going to be. Okay, silver is Ag plus, and chromate is CrO4 2 minus. So they're going to crisscross. So you're going to get Ag2 CrO4. Okay, and the question is asking us to find the molar solubility. So we're going to write Ag2 CrO4 solid, and we're going to break it up into its ions. So we're going to get Ag plus aqueous plus CrO4 2 minus aqueous. But now we need to make sure that the equation is balanced. I have two Ags, so we need to put 2 over there. CrO4 is 1, and we have just one CrO4 2 minus. So good, the equation is balanced so far. Again, guys, this is going to lose some x. Now this is 2Ag plus, means it's going to go up by twice as much. So it's going to go up by 2x. Now this is just 1 to 1, so that's just going to go up by x. My KSP expression will just be Ag plus. Now there's a 2 in front, so that's going to become my power times my CrO4 2 minus, and that's just 1, so it's going to be as it is. So this just becomes 2x whole squared times x, which is 4x squared times x, which is 4x cubed. And we're going to find the KSP of Ag2CrO4 on our solubility sheet, and that should be equal to 1.1 times 10 raised to the power minus 12. Again, guys, we're going to divide both sides by 4 first. Make sure you put brackets. That's going to cancel. And then we're going to take the cube root of that. So we're just going to take the cube root of 1.1 times 10 raised to the power minus 12 divided by 4. And again, if you punch it in properly, you should get 6.5 times 10 raised to the power minus 5 molar. Now guys, what's x? X tells me how much of Ag2Cr4 is going to dissolve. Okay, how many moles per liter of Ag2CrO4 is going to dissolve, which in other words is your molar solubility. So we found our answer. So this is how you're going to be doing your KSP questions, folks. Thank you very much.